In this first part, what we're going to do is look at some techniques to decompose larger fractions. In this particular case, this one is in fact larger, not necessarily harder than the ones we've worked with before. Anyway, if you look at the denominator, this will factor into three linear factors. X would be one of the factors, the other linear factor, x plus 3, and finally the last linear factor is x minus 1. You should be familiar with techniques that lead you to those factors. Anyway, for each linear factor we have a value, in this case a, b, and c. We have constant values a, b, and c, and we're going to solve for those constant values. So anyway, if we were adding these fractions, we would need a common denominator, and the common denominator would be a product of all of the linear factors. So I'm looking at the numerators now. In order to add these up, I would take the a and I would multiply it by the product of x plus 3 and x minus 1. Then continuing in the numerator, we would have plus b times x and x minus 1 plus c times the product of x and x plus 3. Now this would all be over the common denominator of x times x plus 3 times x minus 1. But in this process, all we need to do is look at the numerators. And when we did this process, it would equal the numerator 4x squared, plus 13x minus 9. So the goal here is to find the values of a, b, and c that would successfully decompose this fraction. In this particular part of the lesson, I'm more concerned with you being able to set up a system and not necessarily solving it. In the second part of this video, we will actually solve for the values. Okay, so in looking at this, I want to figure out what are the terms that precede any x squared. So we would have a plus b plus c. They would precede x squared. See, if we FOILed or expanded this, the leading term would be ax squared. Same thing here, the leading term would be bx squared, and here the leading term would be cx squared. So a plus b plus c precedes the x squared. And in similar fashion, we would have 2a minus b plus 3c would precede the x term. And finally, minus 3a. That would be the only constant term, because these terms over here would both have x in them. And finally, we restate that that's going to equal 4x squared plus 13x minus 9. So this leads to a system of equations where a plus b plus c equals 4, 2a minus b plus 3c equals 13, and finally, negative 3a equals 9. So this is a pretty easy one to solve, but I'm going to save the solving for them later. Right now we're just going to skip to the solution. A equals 3, b equals negative 1, and c equals 2. So our successful decomposition, we'll go back to the top, would be 3 over x minus 1 over x plus 3 plus 2 over x minus 1. Now the problem does not ask us to integrate, but in the future, if we were asked to integrate it, then we could integrate this portion, which is a pretty easy integration problem. In example 2, we're going to do the same thing. The difference is I've already factored the denominator, which is nice, but this introduces a new concept here. We don't just have a linear factor, we also have a repeating linear factor. This term here is not considered a cubic factor. It's considered a repeating linear factor. So it might be of interest to you to go to the dialog box on the page preceding the notes to see if you can figure out what to do with a repeating linear factor. Alright, so I'm going to skip to the solution. If you want to press pause and see if you can figure out what to do with a repeating linear, that might be helpful. But if not, we're going to continue. So we have our traditional linear factor, x plus 1. Now, what we need to do with the repeating linear factor is we need an x minus 2 to the power of 1. We also need an x minus 2 squared, and then a final x minus 2 to the power of 3. So we need all the linear powers that proceed up to the final third power. And each one of these, because they're linear, gets our constants a, b, c, and d. Okay, so this gets a little tricky now. Not hard, but just a lot of algebra. So common denominator, but we're looking at the numerator in effort to get a common denominator, would be a times x minus 2 to the power of 3. I don't need this one, and this one, because the first one and second one are embedded in the third one. So it would be a times x minus 2 cubed plus b times the product of x plus 1, and we would need an x minus 2 squared, and then plus c, we would need an x plus 1 and an x minus 2, finally plus d, and we would simply need the x plus 1. Okay, and then that, of course, if I could fit this in here, would equal the numerator, minus 18x squared plus 29x minus 4. Just made it. Alright, again, we have to now collect the different terms. The a, if I were to expand this, x cubed minus 6x squared plus 12x minus 8, and then expand the next portion, we would have x cubed minus 3x squared plus 4, moving right along, c times the polynomial x squared minus x minus 2 plus d, x plus 1. Okay, equals, of course, that trinomial there, or third degree polynomial. Okay, so let's take a look at this. What are the terms that precede any x cubed? Can you see that it's simply a plus b? See, if I distribute the a and distribute the b, those will be two terms that precede an x cubed. Continuing along, plus negative 6a minus 3b plus c will precede any x squared, plus 12a minus c plus d will precede the x. Now our constants, we have a negative 8a, we have a plus 4b minus 2c, and finally plus 1d. So if that's going to equal in the end this, then obviously a plus b is equal to 3. This is going to be negative 18. This portion here is going to be 29, and all the constants together are going to equal negative 4. That's where I'm going to end example 2, and again in the next part of this lesson we will talk about solving that system. Here we are at example number 3. you may want to pause and take a moment to see if you can actually factor that denominator. So we're going to have some numerator, the numerator, over some denominator factored. Now, if you press pause and try this, you may or may not have successfully seen that we need factoring by grouping. So if you factor out of the first two terms an x squared, we're left with 2x minus 1 plus a 4, which factored out of the second two terms to get a 2x minus 1. So from there, we factor out the common factor of 2x minus 1, and that leads us to 2x minus 1 as one factor, and the other factor is an x squared plus 4. So here we go. We actually have something new now. The first factor, this factor here, is linear, but the second factor is not a repeating linear, but in fact a quadratic factor. And that's going to have a different treatment. So above a linear factor, we have the constant a, but above a quadratic factor, press pause, look at that dialog box. What goes above a quadratic factor? Okay, above a quadratic factor goes a general linear factor. So I'll say bx plus c. Okay, now we need to decompose this, continue in the decomposition. So our numerator a times x squared plus 4 plus our factor of bx plus c multiplied 2x minus 1 will equal our numerator of x squared minus x minus 21. A fairly easy one to solve here. Let's take a look. What precedes x squared? Well, we're going to have an a. If I FOIL this here, these first two terms, I'm going to get a 2bx squared. So I need a plus 2b to precede the x squared. Next, what precedes the x? So I like to say plus minus b plus 2c will precede the x. And finally constants, a plus 4a and a minus c equals x squared minus x minus 21. So these two will have to equal 1 because the coefficient here is 1. These will equal negative 1, coefficient here, and the constants will equal negative 21. Let's actually take this one out a little bit. So we have a plus 2b equals 1, negative b plus 2c equals negative 1, and finally 4a minus c equals negative 21. Dot dot dot, we'll solve it later, but a will come out to be negative 5, b will come out to be 3, and c will come out to be 1. To finalize our decomposition, negative 5 over 2x minus 1 plus 3x plus 1 over x squared plus 4. For example 4, I encourage you to think of everything you've seen in this lesson so far and think about how you would deal with the denominator here in effort to decompose. So press pause, see if you can figure it out first, and then go back to the video and follow along. And I will begin now. So the denominator, we see we have a nonlinear, we have a quadratic term, and the quadratic term is repeating. So what do we need down here? Well, for this part, we can do x plus 1 squared, and then I would need an x plus 1 to the power of 1. Again, we need each of them. If it's x squared plus 1 to the 5th, we need to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st. And then above it, because they're quadratic, we need linear generals. So ax plus b plus cx plus d. and let's take a look. So we have ax plus b. We wouldn't need to multiply that by anything because the common denominator is x squared plus 1 squared. So I don't need anything to that one. The other one, however, I do need a cx plus d times another x squared plus 1. And let's see what that's going to be. I'll expand it. So I have ax plus b, and then in the second part I have plus cx cubed. Again, I'm expanding this portion. Plus cx plus dx squared plus d. Fairly easy one here actually now, because we have cx cubed. C is the only term preceding a quadratic, plus dx squared plus a plus c will precede x plus b plus d equals the numerator. So we see right away that c has to be 5, d has to be -3, a is 2, and b is 0. So what does our decomposition look like? Well, I have 2x over x squared plus 1 squared plus 5x minus 3 over x squared plus 1. In the last example, example 5, I'm actually asking you to integrate it. So don't just decompose, but integrate it. Press pause. This is actually an easy one. You can go from start to finish, press pause, do it, and then check your answer. Here we go. Alright, first I'm going to look at the 6x plus 7 over x plus 2 squared for decomposition. It's a repeating linear, so I have an x plus 2, and then I need the x plus 2 squared, constant. Fairly easy process. You will learn that a equals 6, b equals -5, so we are looking at 6 over x plus 2 minus 5 over x plus 2 squared. Then when we integrate this, 6 over x plus 2 dx minus 5 over x plus 2 squared dx. In the first one, it's going to be 6 natural log absolute value x plus 2. That's a funny natural log here. Now this one, please don't abuse the natural log. This is 5 x plus 2 to the -2 power, and that integrates to be plus 5 times x plus 2 to the -1 plus c. That concludes part 1 of the lesson, where we essentially are finding systems for A, B, C, D, etc. In part 2, though, we're looking at some perhaps advanced techniques to solve the systems, including some from linear algebra. So please watch that video and be prepared to follow systems as such.